Hi everyone, thank you so much for coming to our poster talk. My name is Chandra Taposeea-Fisher and I work for CGI. Today I'm talking to you about our brand new project, one of the Digital Twin Earth Precursor projects, an ESA-funded project specifically focusing around food systems. Run by CGI, building upon our experience in PDGS and the thematic exportation platforms, this project is working closely with Oxford University Innovation and Trillium in the UK, as well as EASA based in Austria. This project is part of ESA's Digital Twin Earth Precursor project, starting this year and focusing on supporting ESA in the definition of a concept of a digital twin Earth and establishing a solid scientific and technical basis to realise the EU's data strategy to launch a Destination Earth initiative. A horizontal component, led by CGI, will focus on common elements of DTE architecture and shared building blocks of end-to-end implementation. The vertical component, led by Oxford and supported by Trillium and EASA, focuses on specific applications, science domains, and use cases to complement horizontal components. Our project will focus on a food systems digital twin, looking at a use case with the prominent use of AI processing, challenges of model integration, ingestion of socio-economic as well as physical measurements, end-to-end chain providing decision support outputs, all with meshing innovation at each stage and working closely with a series of stakeholders at every step. There are several tasks within this project. Task 1 will focus on stakeholder engagement and DTE consolidation. Task 2 will look at DTE development and iteration. Task 3 will be about implementation and future roadmap. And Task 4 having promotion and communication to keep the user community fully informed of our progress. The purpose of this use case is to demonstrate the value of DTE concept to the scientific community by integrating the outputs of novel algorithms. We will be using selected machine learning extreme precipitation models, feeding global gridded crop models, and after a regional downscaling exercise, the integration into cropland land use and pricing. By doing these steps, the benefits include improvement in routine monitoring with regular seasonal progress, short-term policy development, including responses to crop shortages due to extremes, and aiding in long-term policy development to apply appropriate incentives. The purpose of the architecture and integration within the preparation of the demonstration is to support the use case and draw conclusions for the roadmap. The architecture and integration is very complex overall, and as you can see, only the green components will be demonstrated in this project, so we still have a lot of future work to do. There will be development based on user consultation and drawing together the three model elements. There will be an agile approach to the project with two 3-month iterations and a lessons learned to support the roadmap. The following elements represent some of the challenges that we will be working on within the project. Scale, we need to have a high-resolution complex system working on model refinement and accuracy. The communication between elements will deal with large data volume and rates, such as AI training with high link performances. Model interactions at all scales for the processes that need to be simulated with higher resolution performances. The integration of external models is also a key factor to be accommodated, needed to facilitate model comparisons. Error and uncertainty propagation for the end-to-end assessment of errors, uncertainties, and misrepresentations. Closely tied in with this is quality and validation needed at each stage, and especially important for cross-validation of AI applications. Socio-economic integration, which is a major challenge in its own right, ensuring stakeholders are engaged and aligned at objective processes and initiatives, and finally the rate of progress, as it is a highly complex undertaking. The DTE is an exciting project bringing together ER experts, Earth system scientists, industry, AI experts, modelers, ICT experts, and user community. It is to establish the initial building blocks of such an ambitious initiative and, based on the prototyping activities, the development of a scientific and technical roadmap for the future. Thank you so much for coming to our poster talk. I'm excited to work on this project and see it develop. Please visit us in our virtual booth if you would like to find out more.